Graphing absolute value functions. The general form of an absolute value function is y equals a times the absolute value of x minus h plus k. We did some explorations, some investigations earlier in the week, and we learned that when we changed the number on the outside, it moved the graph up or down. When it was positive, it went up, and when it was negative, it went down. We call those a vertical translation. We said positive moved it up and negative moved it down. And when we did that investigation, we noticed something different about the horizontal translation. When we added on the inside, it actually moved it to the left, which is opposite from what we thought it would do. And when we subtracted, it moved it to the right. And that has to do with what makes the inside of the absolute value equal to 0. The number on the outside, the a, is actually the slope of the lines. An absolute value function is a V-shaped graph, and each part of this V-shaped graph is a line with a positive slope on this side here and a negative slope on this side. So our parent function is y equals the absolute value of x. When a is positive, it's always going to open up, like we see up there. But when a is negative, when it's less than 0, the graph actually opens down, and we call that a reflection in the x-axis. And when the absolute value of that number in front, so we ignore the sign because the sign determines whether it opens up or down, that number, if it's greater than 1, it actually makes the graph steeper or narrower, and we call that a vertical stretch. We'll talk about the vocabulary a little bit later next week. When a is less than 1, meaning between 0 and 1, really, like 1/2, it actually makes it a wider V because we're changing the slope of those lines. So if the slope becomes 2, instead of going up 1 over 1 like you would on the parent function, you're going up 2 over 1. And for the wider graphs, you're going up 1 over 2, and that's why it's making the function wider. So we're going to look at a few examples. We want to look first at telling whether the graph opens up or down, whether it's narrower or wider than the parent graph, y equals the absolute value of x, and we want to state the vertex. And then we'll graph these on the next slide. So if I have the function f of x equals negative 2 times the absolute value of x plus 2 minus 3, does this function open up or down? This negative means it opens down. Now the a is equal to 2, which is greater than 1, which means the graph is going to be narrower. And I just want to be consistent, and I'm going to just introduce the vocabulary. This is going to be a vertical stretch. Narrower means it's stretching it out by pulling the vertex down vertically. And then what is my vertex? Well, remember that it moved opposite. So from 0, 0, if I add, it moved it to the left 2, and to the left 2 is the point negative 2. And when I subtracted on the outside, it moved it down 3. So my vertex is negative 2, negative 3. Let's look at g. G of x, 1/3 times the absolute value of x minus 4 plus 2. Because the 1/3 is positive, it should open up. 1/3 is less than 1, so this is actually wider than my parent function, y equals absolute value of x, and we're going to call that a vertical shrink. And my vertex, so remember we said it was opposite, so when it was minus it moved to the right. So to the right 4 is positive 4, and positive 2 means it moves it up 2, so the vertex is 4, 2. So we're going to take that information and now we're going to graph it. So the first function was negative 2 times the absolute value of x plus 2 minus 3. We said the vertex is negative 2, negative 3. Remember, it's opposite of what's going on inside the absolute value because negative 2 makes this 0. So I'm going to draw that point on my graph, negative 2, negative 3. And then I'm going to look at A. A in this case is negative 2, which means it's going to open down. I want to remember that. So from my point, I'm going to use negative 2 as a slope. I'm going to go down 2 and to the right 1, and that's going to give me 1 point on my absolute value function. And then I'm going to go down 2 and to the left 1. That gives me my second branch. And when I connect them, it looks like this. I don't like that. Let me do it the opposite way. There, now my arrows go in the right direction. And there is my absolute value function. This is actually one of my favorite ones to graph because it is 2 lines together, and so it's pretty simple to graph. We just use A as a slope. We go down 2 in the right 1 and down 2 into the left 1. That gives us both branches. Now let's talk a little bit about the domain and range. The domain of this function is all real numbers, x such that x is contained in the set of all real numbers, because I can plug anything into the absolute value graph. If I were to bring those, the arrows mean it's going continuing in both directions, right and left. But if I look at my range, the graph kind of stops there at negative 3. So my range, not kind of, it does, is y such that y is less than or equal to negative 3. So my range is always going to be less than or greater than the k, depending on whether the graph opens up or down. Let's look at our second example. My vertex again is opposite of what's inside the parentheses, so it's 4 minus 4 would give you 0, so 4 is your h or your x value of your vertex, and 2 is the y value of your vertex. And your A is 1/3 positive, which means it opens up.
All right, ladies and gentlemen.
It opens up. So I'm going to draw my graph 1, 2, 3, 4, up 2. Here's my vertex. And A is a slope again. So 1/3, a slope of 1/3 means go up 1 and to the right 3. So I'm going to go up 1 and to the right 3, up 1, right 3 for the first part of my branch. And then I'm going to go up 1 and left 3 for the second part of my branch. I'm going to connect the points to make my V. And that's my graph. Now my domain, again, the domain on all these functions is x such that x is contained in the set of all real numbers. And my range, in this case, y such that all of my points are greater than this 2. So y is greater than or equal to 2. That's my domain and range.